Hey guys, here's the review for spiral number 9. Here we're going to be doing some factoring. Here we're not trying to solve, we don't have any equations. So my goal is to factor this as much as possible. I don't see a third term here, so I can't use my quadratic factoring by grouping. What I can do is try to see if there's anything these guys have in common. And I notice that 25x squared and 45x can both be divided by a 5 and by an x. When I perform this operation, I get 5x left over out of 25x squared, and I get plus 9 left over out of 45. Just to double check, 5x times 5x is 25x squared. 5x times 9 is 45x. And in fact, this is completely factored at this point. We factored out a common factor, and there's nothing else that we can factor out. Here we're doing some factoring. Our goal is to find some terms that multiply to get this. Since I've got a quadratic term, a linear term, and a constant term, we're going to try to apply our factoring methods. First up, I'm going to multiply my first and last term. So a times c is equal to negative 150. Okay, I'm going to try to find things that multiply to negative 150 and add up to 19. I'm going to start with negative 1 and positive 150. That's way too far off. Negative 2, 75. Nope, still too far off. Negative 3 and 50. That's 47. Negative 4 doesn't work to get a fraction. Negative 5. And negative 5 times 30 would be 150. That gives me 25. Now we're getting closer to 19. Negative 6 times 25. And here I get my answer. So negative 6 times 25 is negative 150. And negative 6 plus 25 is negative 19. This is what I'm going to use to set up my grouping. 10x squared minus 6x squared plus 25x, sorry, it should be 6x, and minus 15. All right, first two terms, these guys have a 2x in common, and I'm left with 5x minus 3. And just to double check, 2x times 5x is 10x squared. 2x times minus 3 is minus 6x. Okay? 25x and 15 have a 5 in common, and we're left over with 5x and minus 3. And just to double check, 5 times 5x is 25x. Okay, and 5 times minus 3 is minus 15. Nice. At this point, we look at our common factors again. Now I've got a 5x minus 3 in common. I'm going to undistribute that. So 5x minus 3. And my remaining pieces are 2x and plus 5. This is fully factored. In this problem, we don't have to solve anything. We don't have an equation, so we're just trying to factor this completely, which at this point we have done. Here we're trying to solve by factoring. I've got 5x squared minus 15x minus 140, and I see that in my brain's like, I don't want to deal with that. So one of the things that I try to do before I begin factoring is I'm going to attempt to see if there's anything that I can divide all three of these by, and in fact, all three of these are divisible by 5. If I divide everything by 5, I get 0 is equal to x squared minus 3x, and 140 is going to be minus 28. Cool. I've rewritten this problem in a much easier to digest form. If I multiply my first and last term, I get negative 28x squared, and I'm trying to add up to negative 3x. So multiply to negative 28, add up to negative 3. So I might start with negative 28 and 1, and that adds up to negative 27. Negative 14 and 2, that adds up to negative 12. 14, 3 doesn't work. 4, negative 7 and 4, I get negative 3. That's my answer. Okay, so we've got 0 is equal to x squared minus 7x plus 4x minus 28. All right, first pair. They just have an x in common, and I've got x minus 7 as my leftovers. To double check, x times x is x squared. X times negative 7 is negative 7x. Cool. Okay, 4x and 28 have a 4 in common, and I've left with x, and 28 divided by 4 is going to be 7. So x minus 7. Okay, and just to double check, 4 times x is 4x. 4 times minus 7 is minus 28. Nice. All right, now I've got x minus 7 in common. X minus 7, and my leftover pieces are x plus 4. This thing is still equal to 0, which means we do have some more work. We have to solve this. If one of these things is 0, that means the whole thing would be 0. So this could be either x minus 7 is equal to 0, in other words, x is 7, or x plus 4 is equal to 0, x equals negative 4. Here we're doing some factoring to solve. I don't love having a negative a term, so what I'm going to start off by doing is multiplying my entire thing by negative 1 to make this 4x squared minus 17x plus 15 is equal to 0. Okay, same process. 4 times 15 is going to be 60x squared. My middle term is minus 17x. So now I need to find things that are negative and multiply to 60. Negative 1 and negative 60. That gets me negative 61. Okay, negative 2, negative 30 gives me negative 32. Negative 3, negative 20 gives me negative 23. Negative 4, negative 15 gives me negative 19. Negative 5, negative 12 gives me negative 17. That's our winner. 4x squared minus 5x minus 12x plus 15 is equal to 0. I factor the first pair, I get just an x in common with a 4x minus 5 left over. And just to make sure, x times 4x is 4x squared. X times minus 5 is minus 5x. For negative 12x and 15, I'm going to take out a negative 3. I like taking out the negative to try to make sure that I get a positive inside the parentheses. And negative 12 divided by negative 3 is going to be 4 with my x. And I get a minus 5 for 15 divided by negative 3. Just to check, negative 3 times 4 is negative 12. Negative 3 times negative 5 is positive 15. Those both work out. My common factors are now 4x minus 5. That comes out front, 4x minus 5. My leftovers, x minus 3, are equal to 0. Since this is still trying to solve, we're doing 4x minus 5 is equal to 0, and x minus 3 is equal to 0. In other words, x is equal to 5/4, and x is equal to 3. Here we're doing some completing the square. This one's already cleaned up for us. So I'm going to start off by moving my terms around. I'm going to split up my middle term, which here is 7x. We get x squared minus 3.5x. I don't know why I'm using decimals, but that's okay. Minus 3.5x plus some number is equal to negative 3 plus some number. Okay. 3.5 is really 7 over 2. That's a little bit easier for me to multiply with. So 7 times 7 is going to be 49. And 2 times 2 is going to be 4. 49 over 4 is what I have to add to both sides. All right. The left side is going to end up factoring to x minus 7 over 2 squared. And the right side, I know that negative 3 is going to be negative 12 over 3. What am I talking? That should be 12 over 4. Just to find a common denominator. Negative 12 plus 49 is going to be 37 over 4. All right. From this point, I'm going to take the square root of both sides. I get x minus 7 over 2 is equal to plus or minus the square root of 37 over the square root of 4. In other words, plus or minus the square root of 37 over 2. And finally, we've got to add 7/2 to both sides. And we get x is equal to positive 7 over 2 plus or minus the square root of 37 over 2. All right, here we're going to complete the square. I need to clean this one up, so I might start by adding 165 to both sides. So I get 11 squared minus 121x. Sorry, 11x squared minus 121x is equal to 99 plus 165. At this point, I'm going to divide everything by 11. Don't know why I didn't combine those two first, but that's okay. 11x squared divided by 11 is x squared. 121x divided by 11 is going to be negative 11x. 99 over 11 is going to be 9. And 165 over 11 is going to be 15. So we get x squared minus 11x is equal to 24. Okay, now that we've cleaned up, we can start completing the square. Getting to break up my middle term to two equal pieces. X squared minus 11 over 2x minus 11 over 2x plus, and if I square this, I get 121 over 4 is equal to 24. And again, I'm going to add that 121 over 4 to both sides. Okay. 24, I want to convert that to a fraction over 4. It's going to be 96 over 4. 96 over 4 plus 121 over 4 is going to be 211, 217 over 4. That's a nice number. And this guy's going to turn into x minus 11 over 2 squared. Taking the square root of both sides, we get x minus 11 over 2 is equal to plus or minus the square root of 217 over the square root of 4, which is 2. So that should be a minus over there. Now, finally, I'm going to add 11 over 2 to both sides. I get 11 over 2 plus or minus the square root of 217 over 2. That's my final answer. Here we're going to be solving using square roots. If you weren't aware of this, one of the hints you can use here is that we don't have any terms besides an x squared or something in parentheses squared, and that gives us the ability to just treat this as kind of a get the x by itself problem. Although in this case I want to get the x squared by itself first. So I'm going to add 50 to both sides, and I get 10x squared is equal to negative 100. Divide both sides by 10. X squared is equal to negative 10. I'm going to take the square root of both sides. X is equal to plus or minus the square root of negative 10, which I cannot leave as an answer. I have to write that as plus or minus the square root of 10 multiplied by I. In other words, 10 times the square root of negative 1.
Good morning. Hi.
Next problem, we got a really similar setup. We're looking at 100x squared minus 36 equals 0. I'm going to add 36 to both sides. We get 100x squared is equal to 36. Divide both sides by 100. X squared is equal to 36 over 100. Now I'm going to take the square root of both sides, and I get x is equal to plus or minus the square root of 36 is 6. The square root of 100 is 10, which could be reduced into plus or minus 3/5. Here we're trying to get the x squared by itself, so we can take the square root of both sides. First thing I'm going to do is divide both sides by 8. And here we get x squared is equal to negative 32. Okay, I'm going to take the square root of both sides. I know this is going to be an imaginary number, so we get x equals plus or minus the square root of 32 times I. I'd like to take this further by breaking this down. I could rewrite 32. The biggest perfect square factor I can find in here is going to be 16. So it'd be 16 times 2, because 16 times 2 is 32. And then an I. Square root of 16 is 4. X is equal to plus or minus 4 square root of 2 I. Here we got to deal with some imaginary numbers and the process of simplifying expressions containing them. First thing I'm going to do is maybe distribute this I to these first two pieces. So we get 3I minus 4I squared. That's going to be multiplied times 2 plus I. In other words, 3I plus 4, because I squared is going to be negative 1. Negative 4 times negative 1 is plus 4. All right, the other piece is going to be 2 plus I. We can do some double distribution. 3I times 2 is going to be 6I. 3I times I is going to be 3I squared. 4 times 2 is going to be 8. And 4 times I is going to be 4I. First thing I got to do is to figure out what happens with this I squared. That becomes a negative 3. So we've got a negative 3 in here. And my 6I and 4I can be combined to get 10I. So 10I minus 3, and then plus 8. These two combine to make a plus 5. My final answer, written in a plus bi form, would be 5 plus 10I. In trying to rationalize this denominator, what we're going to do is to multiply both the top and the bottom by a conjugate. If I've got 2 minus 3i in the bottom, I've got to have 2 plus 3i being multiplied by the top and the bottom. On the top, we get 6 plus 9i, and on the bottom, we get 4 plus 6i minus 6i minus 9i squared. My middle terms cancel to 0, and I squared is going to be negative 1, which makes negative 9 times negative 1 positive 9. 4 plus 9 is 13. That's my denominator. We get 6 plus 9i in the numerator. Here we're trying to find the absolute value of a complex number. And what I'd like us to remember is that this is basically the Pythagorean Theorem. We're going to take the square root of the first thing squared plus the second thing squared. Okay. And we get 9 plus 25 is 34. The square root of 34 is not our answer, because 2 squared is definitely not 9. 2 squared is 4, plus 25 is going to be 29. Okay. Here we're looking at some quadratic models. We're given a equation that gives us the function of height as a function of time, and that's going to be this negative 16 t squared plus v sub 0 t plus h sub 0. In other words, the height at any time t is equal to negative 16 multiplied by the time squared plus your initial velocity upwards times the time, and adding to that the initial height. Okay, a rocket is launched from the ground with a velocity of 128 feet. I'm going to write v0 over this because that's our initial velocity. And from the ground, that's my initial height, and that's going to be 0. Okay, so we've got h of t is equal to negative 16 t squared plus 128t, and then plus 0. All right, How long is the rocket in the air? In the air means that it's not back to 0. In other words, I'm going to find my zeros or find my roots. These things look like this as far as their path. We know my initial 0 is at 0. We got to figure out what that second number is. So I'm going to set my equation equal to 0. So 0 is equal to negative 16t squared plus 128t. I can divide both of these pieces by 16. And in doing that, so I'll go by negative 16. And I get 0 is equal to t squared, and 128 divided by negative 16 is going to be minus 8t. Okay, this is factorable. This is going to factor a t out of each, and we get t is equal, or t times t minus 8. That means that time is equal to 0, or time is equal to 8 at these points. When does the rocket reach its highest point? We could think about this in a couple different ways. One way would be to complete the square. Maximum height is going to be our vertex. Another way to think about this is that if we know that parabolas are symmetric, which they are, the maximum height is going to occur exactly halfway between my two zeros to make this symmetric. So if I go from 0 to 8, my maximum height would be at t equals 4. And that's halfway between 0 and 8. All right, and then to figure out what that height is, I've got to plug 4 into my equation. So h of 4 is equal to negative 16 times 4 squared plus 128 times 4 plus 0. Negative 16 times 4 squared is going to be negative 256. 128 times 4 is going to be 512. Plus 0, the whole thing is going to be at 512 feet. Last piece, how high is the rocket at 2 seconds? All we're doing here is plugging in 2 for t. So h of 2 is going to be negative 16 times 2 squared plus 128 times 2 plus 0. And if I multiply this stuff out, negative 16 times 4 is negative 64 plus 256, which is 128 times 2. We end up with 196 minus 4, 192 feet high. Here's an exponent rule problem. I'm going to start by taking a look at the stuff on the inside, then I'll deal with that squared on the outside. First thing I might set up is to go piece by piece. First up, I'll look at my numbers. 3 over 15 is the same as 1/5. Now we'll look at my x's. X to the third over x is the same as x to the third over x to the 1. I subtract the exponents because I'm dividing, and that's going to be x squared, and that's on top. Then I've got my y's. Y to the negative 1 over y to the 6. Negative 1 minus 6 is going to be negative 7. So if I've got y to the negative 7 on top, another way for me to think about that is putting y to the positive 7 on the bottom. And now we're going to square because of this thing. Okay. If I don't want to have to write this out twice, I can square each piece of this separately. So 1 squared would be 1. X squared squared, I'm going to multiply those exponents, would be x to the 4th. 5 squared would be 25. And y to the 7 squared, 7 times 2 is 14.